Okay, so we're going to do a couple of examples of how do we use inverse operations and how do we use the idea, the definition of inverse operation to help solve some problems. So I've got two different types of problems that I'm going to work through separately. So the first thing is determining whether two functions are inverses. So this is where the definition comes in. We're basically going to take the definition of an inverse function and we're going to apply it, okay, and see if it satisfies the if part of the definition, okay? So in this case here, if I wanted to determine whether these are inverses of each other, well, I should be able to compose both of these functions in one way and the other way, and both ways should give me x out, okay? So if I take, first of all, if I just say, okay, let's compose it f circle g of x. Okay, so again, that's the same as f of g of x. And again, if I do that, that's going to be, I'm putting g inside of f. So what is it going to look like? Well, wherever there's x here, I'm going to put in g of x. So basically, I'm doing g of x cubed minus 1, right? Well, what's g of x? Well, g of x is this. So what am I going to do? I'm going to put the cube root of x plus 1, and that whole thing is being cubed, and then I'm subtracting 1. And then, what happens? Well, this is going to undo each other, right? The cube root and the cube are going to undo each other. I'm going to get x plus 1. And then I'm going to get x plus 1 minus 1, right? So this is going to give me x plus 1 minus 1. And then, of course, these are going to cancel out, and I'm going to get x. Okay, so far so good. So it worked this way. I got x out. Now I have to do it the other way. So now I'm going to do g circle f of x, which again is the same as g of f of x. So now, notice that now the f of x, the function f is the inside function. And so now what does this look like? Well, now I'm going to stick f of x inside of g of x. So what's going on here? Well, wherever there's an x, I'm going to replace that x with f of x. So this is going to be the cube root of f of x plus 1. And now I'm going to substitute in f of x. Well, what's f of x? X cubed minus 1. So this is going to be the cube root of x cubed minus 1 plus 1. Now look in here, these are going to cancel each other out, and look at that. I get the cube root of x cubed, which again gives me x. And so now I'm done. Therefore, by the definition of inverse functions, f and g are inverses. And we're done. And so that's how you determine whether two functions are inverse functions or not. You have to do it both ways. It has to work out both ways. If one or the other doesn't work, then they're not inverse functions of each other. Now, how do I find an inverse of a function? Let's say I'm given a function, right? So let's say I give you a function, I say, okay, find the inverse of this function, okay? If you can, right? Now, here's the thing. You can't forget that it has to be a certain type of function. It has to be a one-to-one function. If it's not a one-to-one function, then there is no inverse, and we're done. There's no reason to look for one, okay? Okay, so let's look at these three examples and see if we can find the inverse. So let's look at this here. F is defined, this function f is defined as the set of ordered pairs. And so we have -2, 1, -1, 0, 0, 1, 1, 2, 2, 2. Okay? Notice that none of the x components are repeated. So this is a function, right? But what about the y values? Look at that. We have a repeated y value here, which means 1 is mapped to 2, and 2 is also mapped to 2. So we have two x values going to the same y value. This is not a one-to-one function, therefore there is no inverse. So no inverse exists. Okay, so we're done. Okay, now what about b? Okay, well b is definitely a function, okay, and it is a one-to-one function because none of the y values, the y components or coordinates repeat. So this is a one-to-one function. So now, how do we find g inverse? Now, okay, so now here I'm going to show you some notation. So how do we notate the inverse of g? Well, the inverse of g is denoted as what we call g inverse. Okay, now be careful. This is not g raised to the negative 1 power. This is not 1 over g. Okay, that is wrong. Okay, this is a special notation that just means an inverse function. So this is g. If this is g, then we notate the inverse function as g inverse. Okay, so now, how do we write the inverse of g? Well, with ordered pairs, it's very easy. Okay, how do we do that? All we do is flip the x's and the y's. And so what we do is we get a new set where now instead of 3, 1, it's going to be 1, comma 3. And then instead of 0, 2, it's now going to be 2, comma 0. And then instead of 2, 3, now it's going to be 3, comma 2. Oops. And then last but not least, instead of 4, comma 0, it's now going to be 0, comma 4. And that's our inverse function. Okay, it's that easy. Okay? And then we could have an application type problem, right? Well, the application type problem is where, let's say we have a table of values, we have this data, and this data represents year and the number of hurricanes that we've had in the United States during that year. So, for example, in 2009 we had 3 hurricanes, 2010 we had 12, and so on and so forth. Okay? So now, first of all, does this represent a function? Yes, it does. Because none of the x values are repeated. Okay? And does this represent a one-to-one function? Yes, it does. Because none of the y values are repeated. Okay? So, based on this data, we can write the inverse of this function, which again, we could write it as ordered pairs. Okay? So how would we write this as ordered pairs? Well, let me just erase this. We don't need this anymore. So let me show you how we would write the inverse relationship of the table. Well, we would just, if this is our x, right, the independent variable, time is always the independent variable, so this would be our x, and this would be our y. Well, now we're going to flip those. Instead of x comma y, we're going to write y comma x. So our inverse function would be what? It would be 3 comma 2009. And then it would be 12 comma 2010. and then 7, comma 2011. And then it would be 10, comma 2012. And then we have 2, 2013. And that's the way we would write it. And so that would be the inverse function. Okay, so in other words, when we had three hurricanes, that was in 2009. When we had 12 hurricanes, that happened in 2010. We had 7 hurricanes in 2011. So you see how they're just mapped to each other? And that's it. So these are examples of how we would find an inverse. Now, in the next video, here's the thing. I'm not always going to give you stuff like this, and you're not going to always have things like this to work with. I'm going to give you a function, right? An algebraic expression, right? So I'm going to give you something, a function that's an algebraic expression, and so how do we figure out or find an inverse function for a one-to-one function that's written in algebraic form like this? Well, that's where in the next video I'm going to show you a step-by-step process. It's a very simple 3-step process to find the inverse of any function for any one-to-one function. Okay? And so that'll be next. Thank you.